Welcome to this video where I wanted to actually have a look at different sorts of galactic mergers. So we might be familiar with the fact that galaxies do collide and they can grow as they actually collide, and it's known as a merger. But there are a few different types of galactic mergers that there are, and we're going to have a look at these and the differences between the two. So, for example, a dry merger or a wet merger, which sounds a little bit bizarre, but it'll make a little bit more sense as we go through the video. So galaxies are known to collide, and they typically happen in these large galactic clusters like we have here. So we've got this very large supercluster of galaxies. And although the galaxies are separated by a reasonable amount of space in between them, they do kind of attract each other. They're still dense enough that they actually do collide in these galaxies, in these galaxy clusters. You can also see that there is actually some gravitational lensing in here as well because of the enormous amounts of mass in these clusters. But there are some cases in this image here where you've got some galactic mergers that have happened. So we know that galaxies in these large clusters do collide. And it's one of the routes actually that can turn a spiral galaxy into an elliptical galaxy. As you get two spiral galaxies, they will collide, and then you end up with a much larger elliptical galaxy. And in some of the other videos I did, I'll explain the differences between spirals and ellipticals anyway. But it's important for this one as well. So as they collide, before you actually get an elliptical galaxy, the end result, you get something known as an irregular galaxy. So as the name suggests, they look quite irregular, and it's quite difficult to classify them beyond that. So spiral galaxies, you'll have a code for them, same with elliptical galaxy, but with irregular, they typically are just irregular, really, because they can be any sort of shape because they're distorted. And that's as they're colliding and merging to form this new larger galaxy. Now, as that happens, they typically contain gas. So spiral galaxies will have varying amounts of gas in them. If it's a young spiral, they'll have quite a lot of gas. That gets depleted as they age, but they still have gas in them. And that gas will collapse as they actually merge. So as the galaxies merge, it causes a collapse in the gas in those galaxies in the irregular galaxy that is then formed. That then causes large amounts of young blue stars to form. So blue stars are quite large young stars. You don't get old blue stars because as they age, they get redder and stuff. So if you have a lot of blue stars, it means that they're quite young. They haven't formed for very long. So in these irregular galaxies during the merger, you typically get a sudden spike in these large blue stars or star formation just in general. So here you've got a nice example. We've got two spiral galaxies here that are colliding to form one larger galaxy. So it's in the process of merging. And you can see there's a lot of blue in there, which is from these younger blue stars. And this actually would typically also be known as a starburst galaxy because you've had a sudden increase in the star formation in this galaxy or galaxies as they're forming. So it can be also known as a starburst galaxy with these new stars that are forming. And again, you've got another example here, different stage of the merger process really, but you've got a couple of galaxies that are colliding. You can again see some blue in there from those new stars that have been formed from the collapsing gas. And again, got two spirals here. Well, actually, there's three. There's another one off to the side. But we know for a fact that at least the two in the foreground are colliding and they're tidally distorting one another from their own gravity. And again, you've got lots of blue in there from those younger blue stars. Now, as I mentioned at the very beginning, not all galactic mergers are equal. There are different types. And the two main types really are going to be wet and dry. Now, what on earth do we mean by wet and dry? Sounds a bit bizarre. So a wet merger is gas rich. This means that the galaxies that are colliding have a lot of gas in them, and we would then refer to that as a wet merger. So you've got some 6 examples here of spiral galaxies colliding, and that is a gas rich or a wet merger in process there. And what happens in a wet merger is that you have huge increases in star formation. Again, they might be known as a starburst galaxy, and they will typically be two spiral galaxies because spiral galaxies have gas in them, whereas elliptical galaxies do not. So a wet merger is generally spiral galaxies. You get an increase in star formation, as that gas collapses to form stars on quite a large scale. Now, a dry merger is the opposite. These are typically gas poor, and this would be galaxies that are older or elliptical galaxies that don't have that same sort of gas content in them. So these are gas poor, known as dry mergers. And in this case here, we've got two elliptical galaxies that are colliding. And because there's no gas or very, very little gas left in these, there's going to be almost no increase in star formation. I say almost no increase, it doesn't rule out anything, but compared to a wet merger, these would almost have no change in the star formation rates in comparison, because there just isn't enough gas in there for it to collapse into new stars. So you don't get those bright blue regions as you would do with two spirals colliding. But you can also get a mixed merger. Now, this is a gas poor and a gas rich merger. And what it means really is that you've got one of each type. So maybe you've got an elliptical galaxy that doesn't have the gas content in, and you've got a spiral galaxy that has lots of gas. And what would happen here is the star formation is going to increase in the spiral galaxy because that's the one that's got the gas. Whereas the elliptical galaxy, you're not going to get any star formation occurring in that. But the combined end result galaxy, you're probably going to have more new stars in there than obviously with a dry merger, but not quite the same as if it was a wet merger. So as they actually merge, the galaxies get bigger. I mean, that should make more sense because if you combine two galaxies, their mass increases. But the interesting thing here is that as the mass increases, their color index gets redder. And why does that happen? Well, redder stars are typically older population stars. And as they merge, you deplete the gas. That means there's no gas left to then form new stars. And it means the population of stars gets older, the more and more mass that they get, the more collisions they have, the bigger they get. And as they get to elliptical galaxies, they'll end up being quite red and quite massive. So typically this is the route they would take as they grow and evolve. They get redder and more massive. So thank you for watching, and if you enjoy, then check out some of the other videos.